Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi guys, today we will be looking at Chapter 8, Dispersion and Measurement for Business. This is a continuing chapter of Chapter 7 on averages, where we will be looking at the variability around the average. So, what is the variability around the average? Think of a situation like this. So we have 4, 5, 6 and 7. And to find the average, I'm going to use, we have mean method or mode method or median method. I'm going to choose mean. In mean, we learned that it's the sigma or summation of the total, I would say in this case, values divided by the summation of the number of values. Okay, so the total of these numbers is 22, whereas the count is 4, giving an average mean of 5.5. Now, for a reader, okay, he will look at this data and say, oh, 5.5 is the mean, which means the average of this particular data set, the average number is 5.5. But I want to identify how many are close to this average. How many are close to the average? That is where Chapter 8 answers. Chapter 8 looks at how to show the values close to the average by several methods. So in the exam, they might probably give you, ask you to find the average and then find how many items are near the average. And they won't give you like 4 items. They'll give you probably 20 items or in a very different way. Because the more complex the data is, it's difficult for us as an individual to manually check how many items are close to the average. That's the reason they developed Chapter 8 theories, which shows how we could basically locate and identify the values close to the average. So, well, the main measures they teach us is the range, variance, and standard deviation, coefficient of variance. That's it. Very easy. Let's look what is range. Range is the difference between the highest and lowest observation. Okay, so for example, question, they have asked to calculate the mean and the range of the following data set. If you look at the workings, the mean indicated by X bar, if you recall, is the total of the values given, which is 4 plus 8 plus 7 plus 3 plus 5 plus 16 plus 24 plus 5, divided by how many items? 1, 2, 3, 4, 5, 6, 7, 8. Then you get an average of 9, which means the average data is around 9. However, they said the range formula is highest observation minus lowest observation. So range formula is highest value less the lowest value. The highest value is in this case 24 and the least value is 3. So 24 minus 3, 21 is considered the range in which we can identify a spread around the average. Right? So it's basically 24 minus 3. Okay, but this has some problem. It does not give any indication of the spread between the extremes and is not suitable for further statistical analysis. By seeing the range 21, what do you understand? Do you get any meaning out of it? Any validity around how many figures are near the mean or what anything by this 21? For me, it feels like there are 21 numbers in the dataset. See, so people can judge it very differently because it doesn't set a base to assessing how many values could be near the average figure. It's just 21. 21 doesn't even exist here. And there aren't 21 numbers either. But for some reason, yeah, at some instances it helps, but not always. So actually, it's not a good indication for statistical analysis. So they've developed the concept of variance and standard deviation. So the variance means it looks at the difference between the average and the actual value. Average value and actual value to see how far the actual value is from the average. So basically they want to see how far the actual value is from the average. Well, let's see how it's calculated. Variance is the average of the squared mean deviation for each value in a distribution. You must have thought, well, calculating a variance is simply the difference between the actual and the average. Well, it is. However, we cannot straight away get it in that manner because we need a proper representation of the spread of values across the average. So we cannot really go like a straightforward way, average minus the actual. Even though that is what we do some extra adjustments in getting the real valid variance. So the variance, they've considered it as the average of the squared mean deviation for each value in a distribution. And the symbol of the variance is sigma squared. Now, they might give you this symbol in the exam, so be sure that you are aware of it. And also it's called sigma squared. The deviation is squared to avoid the netting off of positive and negative values of differences. Okay, let's see what it is. Okay, they've told how to calculate the variance for ungrouped data and grouped data. Ungrouped data, first of all, as discussed, find the difference between the actual and the mean average, what I showed here. Average value, which is the mean minus the actual. Then square the difference. That means the answer you have to multiply to the power 2. Now we've learned this in equations chapter and several chapters throughout. That's what is meant by squaring and how do we do it. So basically squared means the difference between this. Let's say example this is 2. So you should write to the power 2. Right? So it's on the top, this one. It has to come above. So this answer, this means 2 multiplied by 2, which is 4. Okay, just a refresher. So be mindful that the difference, the variance answer, the answer that you get from the variance must be squared. Squared means the same number gets multiplied by itself again. And then you get an answer. That's step 2. Step 3, sum of the squares of the difference. Okay, so you get the total of all the differences for each item. Okay, and for each value you get the total, and then have to get the average sum. So these are because we won't have one data. We will be checking the difference between the value and mean for several items, like for example against 4 and the mean, 5 and the mean, 6 and the mean, 7 and the mean, and so forth, right? And in calculating the variance for grouped data, we do the same thing. We don't make any change. However, in step 3, we multiply by the frequency. An example. So let's consider this data set to calculate the variance. So first of all, I'm going to get the variance of each, which is first of all, I'm going to get the mean of each. First of all, I'm going to get the mean of each. So the mean is, as we found out, is 5.5. And now I'm going to get the variance by the steps. So step 1, basically I'm going to take the difference between the mean and the value. Same. So I'm going to fix this, and so basically these are the gaps. Once done, they said to square the differences. That means I'm going to multiply 1.5 by 1.5 itself. 0.5 by 0.5 itself. Minus 0.5 by minus 0.5 itself. Now be sure you use the sign. Now the opposite sign rule applies here, because we multiply minus into minus, which is plus. And then again minus into minus, which is plus. Right. And then step 3, they say take the total. So the total of these are, you can calculate 5. And then they say, what's the 4th step? Average of the sum. So average is 5 divided by how many items? 1, 2, 3, 4. So your average variance is 1.25. It's nearly, right? It's nearly the same. Okay. So the reason they said before, the reason it gets squared is to avoid the netting off of positive and negative. Okay. So because of this minus sign getting multiplied by the minus sign itself, it naturally becomes a plus. Because they deliberately want that to happen, so that the average remains remains a valid one. Imagine this is minus, then your average will reduce unnecessarily because of this minus sign. Due to that, they want to make everything plus. That's why they put this step 2 in by squaring the variance. Okay. So this is basically what you do for ungrouped data. This is not a group, no, this is just data. So this is ungrouped data. Right. Now let's see what's for grouped data. So grouped data, basically let's say a situation where we have 2 to 8. So there's a 6 gap. So I'm going to give 9 to, it's a discrete data, I'm going to give 15, again a gap of 6, and 16 to a gap of 6, 22. I'm going to give the frequency. We learned what is frequency. It will be 2 and maybe 5 and 7. Okay. Now, frequency we know is called F, right? Okay. Now what they want us to first do is find the mean. Same way. So I'm going to take the total of the frequency, which is 14, and 14 divided by 3. So I'm going to take the total of the frequency and I'm going to find the midpoint, because in mean we have to find the midpoint. Now the midpoint, is this a continuous data or discrete data? This is a discrete data. Why? Because it's not continuing from 8. It's starting from 9. So for discrete data, how do we find the midpoint? We basically, what we do, so this is basically greater than 2, less than or equal to 8, right? So it will start from, basically it's not equal to 2, so it will start from 1, not 1, 3, 4, 5, 6, 7 and 8. Now how many numbers are here? 6 numbers. So the midpoint of 6 numbers, it's because it's an even number, and if it's an even number, then we should get the middle value between 5 and 6, because then only it will have a right split. So 5 plus 6 divided by 2 will give me the answer 5.5. So same here, I'm going to change the sign to less than or equal to. Same here where you have 16 and 22. Okay, so here you will be starting from which number? 9, 10, 11, 12, 13, 14, 15. Absolutely, it will not include 9. So it will be 10, 11, 12, 13, 14, 15. The mid value will be 13 plus 12 divided by 2. Then 17, 18, 19, 20, 21, 22. Obviously, again, since these are even number of items, you have to take the middle value by dividing by 2. 19.5. Okay, now what we do next? We multiply the midpoint by the frequency to get fx. So, frequency multiplied by midpoint. Take the total and then take the sum. 210. So the mean is 210 divided by 14, which will give you an answer of 15. Now get the difference between the midpoint and the mean for the variance. So step 1. Okay. So step 1, you'll be having the midpoint. So I'm going to take the midpoints here and 15 here. So we have 15 and then you take the difference. That's step 1. Okay. And step 2 is basically what? Squaring the difference. Multiply by itself. Right? Once you multiply by itself, Yes, you get this. So step 3 is basically, first of all, you have to take your frequencies. Okay, and multiply the frequencies with your step 2 square differences. Basically, because we use the midpoint, but midpoint is not a presentation of the data of a grouped data, no. So you must multiply it by the frequency. Now step 4 is take the, so basically step 3 itself is take the summation of those multiplied answers. And then step 4 is finally the average, which is the number of frequencies, which is um, the total variance divided by the total number of items, which is 14. You get an average variance of, it will be average variance of 25.25. Get it? This is how you work out stuff. Okay, now the main properties of such variances, it's mainly depending on values in the distribution, but not suitable again for further statistics, and it's not in the original unit of data and a bit more difficult to understand. That's why therefore they came to another method called the standard deviation. Standard deviation basically is the square root of the variance and very most important measure of dispersion in statistics. So basically in your exam they might give all of this in one question. The square root, right? The square root of this particular variance 25.25 is your standard deviation. Okay, right. So let's look. But they actually created now, of course, as you saw, the answer of variance is, now how to get the variance is the same variance formula they have inserted inside the square rule. If you see for ungrouped data, this is the formula, this final formula they have put it here, right? And this final formula they put it there for the from the group data. So you must memorize this and very know the meaning of each very well. You can follow the way I did calculate the group data and ungrouped data variance, and same way you could follow to calculate the variance, and simply from your calculator take the square root of 25, whatever the variance that comes for a grouped or ungrouped data. Okay, so this is a question on mean, variance and standard deviation. This is probably how they will ask in the exam. However, please note that there is a small mistake here in calculating the midpoint, because this is a continuous data and they have probably considered everything for each line, which is not right, because 10, if 10 is included in this set, it cannot be considered in this set because it's just greater than 10 only. But if not, there's no proof of a frequency. So I believe these midpoint values are incorrect. However, the method they have followed is fine. So this type of a table you should be able to create when you do your grouped frequencies, as I did previously showed you all. This is a bigger this one. So see, they found the variance, then they took the square root simply. It's super easy. Okay, so the x is the midpoint, they are multiplied, taken the square of the midpoint. So it is, they have juggled around the steps as compared to what I did previously, but it is the same thing. Either you can follow this method or follow the way I taught you all initially here as per the steps, because you arrive at the same answer. they have just broken down. So let me just tell you all what they have done here. Basically, they've considered the midpoint, identified the midpoint, then identified just put the frequency given from the question here and took the total of it. After that, multiplied the midpoint into the frequency to get the summation to calculate the mean. Okay, so from here the mean formula is done. Then for the for the variance, they've just broken the variance formula for grouped data like this into this. I told you all you could mathematically solve, break down equations into parts. Likewise, they have done. So they have taken sigma fx squared divided by sigma f, which is basically x squared means the square of the midpoints you have to take. Then fx squared means square of the midpoints multiplied by the frequency, and then you get your total. So it is f multiplied by x squared is fx squared. Okay, and this 97,500 you must divide by 60, the sigma f. Then that answer you must minus from the sigma fx divided by sigma f. What is sigma fx divided by sigma f? That is the mean. So basically what they have done is, if you look back at the steps, this difference thing they have brought forward straight away into the step 4 by breaking it into two parts. So you don't have to do 1, 2, 3, 4 separately, like you could straight away follow this tabular approach to get the same, or else you can follow these steps. There is no problem, same answer you're going to get. The difference between the value and the mean. So basically you will be getting, so the mean is now 37. So you will put 37 in this column and then take difference between 37 and 5, all of that. And then what you do next is, as they say, square the difference and then take the total. So basically here what they already do is, they first of all square the midpoint, multiply by the frequency, then take the average and then minus it from the mean average, which is also to be squared. Okay. So please follow this method better, because to be on the safe side, but of course you can follow the steps, it's just the same thing. Fine. So definitely you can test both methods and try. Now, properties of standard deviation, they are based on all values and suitable, however difficult to understand. So this standard deviation suitability will be discussed in detail in chapter 10. Okay, so there are certain terms that we need to know in order to be familiar with. We know the mean stands for x bar. This is the sign. Variance is sigma squared, and standard deviation is the root of sigma squared. Let's say where there's a mix of all standard deviation, variance and the mean. They give a question. Nicely listen to this. Daily demand for an inventory item has a mean of 6 units with variance of 4, standard deviation of 2. Demand for any one day is unaffected by demand on previous days or subsequent days. Okay, so the only factor that affects is particular one item, not on other days' demand. So we can juggle around standard deviation, mean and the variance. So they are asking, find the arithmetic mean, variance and standard deviation. Well, arithmetic mean, well, you see here the formula they have given to remember. We said it stands for X bar, but do you notice this N over here? The N is what you need to additionally put to find the arithmetic mean. Now in the arithmetic mean, you multiply the mean by the total number of days, because the days is what affects the mean or whatever. So if you multiply by the days, you get the number of units, because basically what they are saying, what is this mean of 6 units means? That means per day I will be having 6 units. So basically arithmetic mean 6 units means, yeah, 6 units means for one per day the number of items available is 6 units, right? So for all 5 days, how many items? Then 6 into 5, 30 items, no? Absolutely, yeah. So that is the arithmetic mean. Then the variance of the 30 items, so basically you have to multiply everything by 5, because these are items per day. So if you multiply by the total number of days, you will get the total number of units, because they have given the units for one day. Then if you multiply the variance units by 5 days, then you will get the total variance units for all 5 days, which is 20 units. And 20 standard deviation will be 4.47. So basically they have asked to calculate these mean, variance and standard deviation for a demand for a 5-day week. That's the reason we multiply it by 5.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.